Hello, Sola. Thank you for handing in so many assignments. I can see that you've got quite a bit done. I'm also going to email you a list of assignments that you didn't include. I'm hoping that you also have those done and just forgot to upload them into the Dropbox. You're also, once you have those done, you're very close to being able to write the midterm exam. And the midterm exam is just on the calculus part and not on the vectors. The final exam is just on vectors only. And so as soon as we're ready, we'll get you scheduled to do that, and you should have no problem finishing up the course quite quickly now that you've got so much work in. So on your Unit 1 summative assessment, I've got that up here on the screen, and I'd like for you to look at a couple of things with me on it. The first question you did correctly, that's great. The limit as x approaches 5 of the function is 37 because there's no restrictions here, and you can just substitute in their value in for x and actually just calculate the value of the limit. For b, you've done a great job. You've factored the numerator, the top of the function, and ended up with those two factors crossing out, and you're only left with x plus 2. So at this point, if we substitute x equals minus 4 in for x, then we end up with a value of x equals minus 2 for the limit, and that's correct also. What you've got here shows why we needed to factor, and what we've got here is the case of what we call a removable discontinuity. And I know that sounds pretty complicated. All it means is that we have a hole in the graph for this function. If we tried to put it on a grid, there would be a hole in it. It wouldn't be continuous. We wouldn't be able to join our line all the way through. We would have to stop our line at x equals minus 4 and then start it again after x equals minus 4. And we indicate that by an open circle at the value x equals minus 4 on the graph. When I say that it's removable, what that means is that by manipulating the expression for the equation, as you've done here where you've factored, you can actually remove the problem, which is that in the denominator right now we have x minus 4. So if we substitute x equals, we have x plus 4. So if we substitute x equals minus 4 in, we end up with a denominator of 0, which gives us an undefined value, as you pointed out down here. So we can remove that problem by factoring and crossing out these two factors, and then we end up finding a limit at the value x equals minus 4. So that's a case of a removable discontinuity. Sometimes they're not always removable. Let's have a look at the next one. For part C, we've got x squared plus 2x. What was your original equation here? X squared minus 4 on the bottom. So again, we can't just substitute in minus 2 because that's going to give us a denominator that's equal to 0, and that gives us an undefined value for this function. So rather than that, I want you to factor the top, x times x plus 2, and factor the bottom, x plus 2 times x minus 2. That's a difference of squares. Now you can reduce by crossing out those two brackets, dividing x plus 2 into x plus 2. It goes in one time. And now the function that we have left is x over x minus 2. So now let's check and see what happens if we put x equals minus 2 into our function. We're going to get minus 2 over minus 4, and when we simplify that, we get 1 over 2. So the limit of this function as x approaches minus 2 is 1/2. There's another removable discontinuity. And so it's very, very important that you know how to manipulate these formulas and find those factors that will cross out and allow us to find the value of the limit at that point. Looking at D is the same thing. The problem with D is that you've got 3 minus root x in the numerator, and a lot of people have difficulty working with that function. If we have 3 minus root x, 3 plus 3, I'm running out of space here. And so the limit as x approaches 9 for this function is going to be negative 1 over 6. Now, the other issue with this assignment is that there is a question 2 where you're being asked to find a whole bunch of different limits. I don't see question 2 attached to this assignment. I'm going to have to mark the assignment based on what you've sent in, but if you do have question 2 completed and you can turn it in, then I still will mark it and include it in your assignment mark. So that's up to you to decide. If you have any questions about this, please email me and I can make you other videos and send you some more resources. It's a really important concept. It's sort of the base concept of calculus as we're moving forward. So it's a really important thing for you to understand both now and when you go to university. Okay, thanks, Sola.